Today we are covering section 1.1, measuring angles and segments. Go ahead and put your name, date, and period. The objectives for today: communicate precise definitions of angle and segments using the undefined terms point, line, and plane. Use absolute value and the segment addition postulate. Use the protractor postulate and the angle addition postulate. Identify congruent segments and congruent angles. That's a lot of objectives. So let's get into our definitions. A point is a location and has no size. So we're going to put that in the diagram box. And for a point, it's just this, and we can even give it a label, in this case P, but it can be any letter. The notation we use for point is just the letter. So if it was point A, then the notation would just be an A. A line is an infinite number of points on a straight path that extends in two opposite directions with no end and has no thickness. So most of you probably know what a line looks like, and we're going to draw it in the diagram. And you only need 2 points to make a line, but in the definition it says it's full of infinite points. So there's many infinite points. There are points in between A and B and beyond B. And we'll give it a cursive L for line. And then the notation, you can either write it as line L, or more commonly in geometry, the shorthand is we just write from A to B and we put a line on top of it. The next definition is a plane, and this just comes right from our objectives. That first objective, where we're defining point, line, and plane. A plane is an infinite number of points and lines on a flat surface that extends without end and has no thickness. So we'll draw a plane, and it is full of infinite number of points. So put a point X, a point Y, a point Z, and we'll call the plane M. Just like above we called the line L, we're going to call the plane M. Why not P? We already used P for point. So we can notate that as plane M, or we can call it plane X, Y, Z. And there's no shorthand notation for plane. Find segment lengths. how can you find the length of MQ? So we have this line and we have these points, L, M, N, O, P, Q, R. We want to know the length from M to Q. How can we figure that out? There's a few ways we can count. We can just skip count 1, 2, 3, 4. Or we can use the absolute value to find the distance. So a length is like a distance. Okay, so we have Q is at 0.2 and M is at -2. And so we can just subtract those. -2 minus 2. And if we put absolute value bars, it'll give us a positive. If we didn't have absolute value, it would equal -4. So it's the absolute value of -4, right? But when we take the absolute value, we get 4. And so like I said, you can count and figure out it's 4. You may think, well, could we do 2 minus -2 to find the distance? Yes, we'll put that in absolute values. And that, the minus and the negative become plus plus. And it becomes just 4. The absolute value of 4 is also 4. So you can subtract in either order to find the distance. Just remember to take the absolute value. And if you need help with adding and subtracting integers, that's when we have positive and negative numbers, just let me know and I can review that with you. What is a postulate? A postulate is something that comes up in geometry a lot, and it's just a statement that is assumed to be true. A postulate is a statement that is assumed to be true. Okay, so I have some postulates in this lesson to go over with you. The ruler postulate. Every point on a line can be matched with a unique real number. The real number that corresponds to a point is the coordinate of the point. And you can see an example here of a ruler, and we have A is at 2 and C is at 5, and you can find the distance either doing the absolute value of 2 minus 5 or the absolute value of 5 minus 2, both equal 3. The next postulate is the segment addition postulate. If points A, B, and C are on the same line, with B between A and C, so look at that, you see points A and point C, and B is between them, then you can say that the segment AB plus the segment BC has to be equal to the length of the full segment, AC. Makes sense? And oftentimes postulates make a lot of sense, and they almost make so much sense that you're like, duh, of course that's true. And so we have in geometry ways to define what we're saying so that we can prove more difficult things to be true based on these more simple postulates. Okay, turning the page. Let's put this into practice. Use the segment addition postulate. And we have 2 problems to do. If LM equals 19, what is LN? A measure of LN. All right, so they say that LM is equal to 19. Well, to be able to figure out ln, the whole thing, we have to figure out what x is. So let's just work with the blue right now. We have L to M, and they gave us an algebraic expression. They gave us 2x minus 5. But then they also told us that Lm is equal to 19. So we can say that it's equal to 19 because both of these are Lm. Okay? Whoa, did not mean to erase all of that. 2x minus 5 equals 19. Both of those are equal to Lm. Now we have, instead of just an expression, we have an equation, and equations we can solve. So back to your algebra, we add 5 to both sides and get 2x equals 24. Divide by 2, x equals 12. Are we done? No. They asked us to find L to N. So we're trying to figure out this whole segment. What is that equal to? And so we can say that Lm plus Mn, that's this piece in the red, is equal to the whole line, Ln, because that's what we're trying to figure out, Ln. Well, we know Lm is 19. We figured that out, or they gave us that. We could also put in the algebraic expression 2x minus 5, but we'll just use 19, plus Mn, which we don't know what that equals, but we do have an expression, equals Ln. Okay, we know what x is because we figured that out back on this side. So we are going to plug in x as 12. Plugged that in right here because we have x right here. And just bring down the minus 10 equals Ln. Now we're just going to do this arithmetic. 19 plus 12, that is 31. 31 minus 10 is 21. Let's see if that makes sense. Let's just put into x the 12. So we have 2 times 12 minus 5, and we have 12 minus 10. So here we have 24, 2 times 12 is 24, 24 minus 5 is 19. Well, that's what we got before, 19. And then 12 minus 10 is 2. This is not drawn to scale. And so 19 and 2 gives us 21. We got it. Okay, this next problem is very similar to the last. I'm going to color code a little bit. AC equals 120. What are AB and BC? Well, the whole line segment is AC, and that is 120. They want us to find the length from AB and the length from BC. Well, before we can do that, we need to figure out what x is. So we're going to write an algebraic expression using the lengths AB plus BC, and knowing that that is going to equal AC. So AB, we get from up here, is 4x plus 6, and BC is 7x plus 15, and AC is 120. All right, we're going to combine like terms. So the 4x and the 7x give us 11x. The 6 and the 15 give us 21. And we just bring down the equals 120. Next, we're going to subtract 21 from both sides. When we do that, we get 99. And this canceled, the 21's canceled, and we have 11x equals 99. If you divide by 11, you get x equals 9. So now we can figure out by just plugging this x back into this x and to this x, we can figure out what AB and BC are. So AB, that is 4x plus 6. We're going to plug in the x, which we figured out was 9. And that is 4 times 9, 36, plus 6 equals 42. Okay, running out of space here. So now we have to figure out BC. BC was 7x plus 15. We're going to plug in the 9 to the x to figure this out. So 7 times 9 is 63. 63 plus 15 is 78.